Marco Calzi, and I'm the General Manager of Enolfactive, and I am a consultant. Today I'm gonna present about this innovative machine called Mastermind Remove Plus, MMR Plus, and the title of my presentation is Membrane Contactors and Innovation in the Management of Gases Throughout Winemaking Process. Focus on oxygen and sulfur compounds reduction. So the compounds responsible for the wine fault that we call reduction. So we're going to start with the importance of gases in winemaking. So I'm going to start with oxygen. It is beneficial for the yeast rehydration, and it helps conducting a efficient alcoholic fermentation. It is also important for the color stabilization. But we have to beware of oxygen while we press and we before bottling, because the dissolution of oxygen can be detrimental to the wine, and also white wines are very sensitive to oxidation. About CO2, we use CO2 for inerting, for example, in the step of cold settling. It is extremely important, of course, in the sparkling wines, because it forms the bubbles, and it is important also in ready-to-drink young wines, giving some freshness. We need to pay attention to CO2 when we're dealing with red wines with aging potential, because CO2 synergizes with the tannins, and so increases the astringency of the wine, and also with the bagging box. Now, in this slide, I'm going to show you the most recurrent volatile sulfur compounds that are present in the wine, and those compounds are responsible for the what we call the wine fault called reduction. So in the first column you see the compounds, and second column is we see the common descriptors, and the third column is we see the thresholds. So I just wanted to highlight the difference between the first three molecules, which are the mercaptans, and the last two, which are the disulfides. And if we look at the third column, you see that the thresholds for the disulfides are much higher than the mercaptans, and I'm going to get back to this point later on in my presentation. So we're going to start with the occurrence of oxygen dissolution. When and where it does occur, we have to pay attention during the cold settling, the racking and transfer. We can have oxygen dissolution, filtration, of course, post-refrigeration, and also watch out for the small wine lots within oversized tanks, for example, so where we can have easily dissolution of oxygen. The occurrence of CO2, I'm not going to go through the details of this presentation, because it is quite well known that CO2 is produced during alcoholic fermentation in large amounts, but also in smaller amounts. It is also produced during malolactic fermentation. The problem is that during winemaking process, CO2, carbon dioxide, is difficult to manage. So based on the enological objective, it is important to manage gases in wines with precision. What are the gas management methods that are currently available? So mainly there are two. The first one is ceramic membrane cartridges that are used for inert gas stripping and addition of CO2. And also this last technology called the membrane contactors technology. So ceramic membrane cartridges. The problem is with this method is that the precision is quite poor. They are non-selective, so you can have a stripping of potential stripping of positive aromas. The efficiency is quite poor, and also if we use it to add CO2, the perlage, so the bubbling is quite coarse, so the bubbles are not fine. Back in 2013, there has been a resolution by OIV, Organisation Internationale de la Vigne et du Vin, that authorizes the use of membrane contactors during the winemaking process. And I just wanted to highlight here, see in bold, that this is a physical method, okay, which means that the wines doesn't have any interaction with the membrane. The only thing that it is accomplished is that we can exchange gases, so adding certain gases or eliminating certain gases like oxygen. So membrane contactors, what are they? What is it? Microporous, it is a microporous hydrophobic fiber. It does not allow the transfer of liquids, but it does allow the transfer of gases from and to the liquid, so we can add or subtract, eliminate the gases. And schematically, here you see a picture and that shows the way it works. So on one side of the membrane, we have the wine flowing. The other side, we have either the vacuum or we have a inert gas like nitrogen. And through the pores, micropores of the membranes, we have the exchange of the gas, and the exchange of the gas occurs based on the law of Henry, the gases, and the parameters that are important to monitor are the initial concentration of the gas, the temperature, and the delta pressure. Now, just a few slides to show you and simplify the way that membrane contactor works. So the membrane contactor that is used in the Mastermind Remove Plus machine allows only very small molecule with the molecular weight below 50 to pass through the pores, to be exchanged, okay? And these volatile compounds are shown here. Basically, there's what goes through the pores. There's a CO2, the oxygen, the hydrogen sulfide, the methanethyl, and the acetaldehyde when it's free, because when it is bound to sulfides, it doesn't go through the pores, okay? And again, positive aromas are not affected, okay, because they cannot go through the pores. So what can be accomplished in terms of gas management with this beautiful and innovative machine? Removal of oxygen and management of CO2. We can add it and also remove it. We can remove H2S and methanethyl, responsible for the reduction wine fault, potential elimination of acetaldehyde when it's free, and management of the alcohol level. So we can also reduce the alcohol level. Here's a picture of the membrane contactor machine, MMR Plus, for an effective management of wine gases. Possible applications during the winemaking process. So we can use this machine at the step of pump over or the transfer racking, post-filtration, but especially in before bottling, because the goal is the main goal before bottling is to reduce the oxygen concentration as much as possible. So what are the enological advantages of eliminating oxygen, for example, starting with oxygen? It preserves the aromatic potential, and also it improves the aging potential of the wine. And highlighted in blue color here, because it is in the themes of these presentations, particularly beneficial for making low or no added sulfite wines, because if we eliminate the oxygen, we can reduce or eliminate completely the SO2, the sulfites addition. CO2 elimination, it is important for the bagging box because it prevents the swelling of the packaging. And in red wines designed for long aging, it improves the mouthfeel and roundness. Addition of CO2 in warm vintages when the acidity is quite low. I can add freshness to white and rosé wines, and also to young, ready-to-drink red wines. And also extremely important and beneficial to the aroma profile of the wine is the elimination of hydrogen sulfide and methanethyl, because it eliminates the aromas responsible for the reduction, and also enhances the intensity of fruity and floral notes. And speaking of on this topic, I would like to show you a study that was conducted at the University of Zaragoza by the group of Professor Vicente Ferreira. So what they did was they took a wine and they added H2S and methanethyl, but below the perception threshold, so you cannot smell rotten eggs and garlic, okay? And then they did the sensory study, and the results were that hydrogen sulfide and methanethyl, they act as a strong suppressors of fruity and floral attributes. So even if they are below thresholds and we eliminate them, we can have an enhanced intensity of floral and fruity notes. So we have to think of that it's extremely important to know that H2S, hydrogen sulfide, is the precursor of the volatile compounds responsible of wine reduction fault, because it is always produced by the yeast and it is necessary for the biosynthesis of essential amino acids like cysteine and methionine. But then, when present, it can react with ethanol, forming the ethanethyl, and during aging, so in the presence of oxygen, the ethanethyl is oxidized to its corresponding disulfide. And same it happens with methanol. We always have little traces of methanol. H2S plus methanol gives methanethyl, and then during aging of the wine in the presence of oxygen, we can have oxidation to the corresponding disulfide, so dimethyl disulfide. But as going back to the slide where I showed the thresholds, perception thresholds, remember that the disulfides, they have a higher threshold, okay, much higher than the mercaptans. And so sometimes what happens is that before bottling, we go to we smell the wine and we say, no, it is not. It doesn't seem that it is reduced, because we have mainly prevalent. We have in prevalence we have disulfides, okay, which sensory threshold is higher. And then what happens is that before bottling, we add sulfites. So, and the redox potential is reduced, and so we go back with the reaction. So the disulfides, they form in the first few months after bottling, they go back to the mercaptans, and so we open up the bottle and the wine is reduced. And so this is the chemical explanation. So therefore, it is desirable to remove H2S before it reacts further to form mercaptans. And this is getting close to the end of my presentation, but I wanted to mention also this article, Beware of Copper. So this study was conducted in Australia after adding H2S to a wine and copper in the form of a copper sulfate, they did racking and or filtration. And filtration was very tight because it was 0.45, 0.2 microns, okay? So the result is that they found negligible concentration of copper, which means that copper does bind to the mercaptans, but it stays in solution. And then it is possible that over time, the mercaptans are released from the copper. And also they found, well, this is quite known, that the residual copper in white wine after racking was acting in mediating the browning. Now, I'm not going to go through all the applications, but I just wanted to mention, for example, the first one of the management of gases. All these tests were conducted in Italy. For Lambrusco, just mentioned the Lambrusco, they did the removal of oxygen and CO2. And so all the results are reported here, but it's a long slide and time is finishing up. And also, I'm gonna end my presentation by showing that in collaboration with the University of Verona, a couple of studies were conducted on the aromatic profile of Valpolicella Classico and also on the aromatic profile of Vermentino. And in all cases, we had an enhancement after passing the wine into the machine of the intensity of floral and fruity aromas. And just showing a few pictures of the MMR Plus machine in some winemaking facilities. And I will thank you everybody for your attention. And just if you need further details, do not hesitate to contact me by email. Thank you very much.